Okay, continuing on today with our Laplace Transform playlist, we have the Laplace Transform of f of t over t. And if you'd like more information on the Laplace Transform, I've got a playlist. I'll provide a link in the description. You can check that out. Now to get started with this, what I want to do is I want to start with the definition of the Laplace Transform. So what we have for that, we use this big F notation for the Laplace Transform of f of t. And we define this in terms of an integral that's going from 0 to infinity of e minus st of this thing, f of t. But what I'm going to want to do with this is just kind of use a different variable, because we're going to want this solution, we want eventually to get back to this as a function of s. So I want to use another variable. Let's just call this u. So we just need to change it here and here. And then what I want to do with this is use this and this. I'm not really worried about this right now. I just want to integrate with respect to u. So doing this, we're going to integrate our big f of u du here. And then over here, when we do it over here on the right side, now we end up with a double integral. I'm just going to leave it like this for now. In the inside, we just have all this stuff, e minus ut f of t dt. But again, this one, we're going to be integrating with respect to u. But now here, we're going to want bounds on this integral. We're not going to want the plus c of an indefinite integral. We're going to want to get back. For this, we want this to become a function in terms of s. So what I can do here is we can create the bounds as going from s to infinity and do the same thing on the right side as well. And that way, when we evaluate all this, we're going to get back a function in terms of s. And so we'll leave this on the left side for now, but we want to go ahead and try to evaluate this. And the thing I notice is in the order we have it here, this is a little hard to deal with because we're mixing variables here. We're integrating with respect to t. And we've got both variables u and t. What I can do here is just swap the order of integration so that we're on the outside integrating with respect to t. So we'll have this one going from 0 to infinity, and then on the inside we'll be going from s to infinity. We don't have to worry about altering the bounds because this is just going to be a rectangular region. So when we do this, we'll just copy all this other stuff down. But now we're integrating here with respect to u, and we have the dt on the outside. But doing it like this, now this f of t value, this is just a constant value with respect to u. So I can bring this outside of this integral anyway, bring it right there. So when we do that, let's see, now we're going from 0 to infinity. We have our f of t on the outside. But now this integral on the inside, this is just something we can go ahead and integrate. So doing this, we still have this stuff out front. We're going to have this f of t here. But then integrating just this part with respect to u, first we're going to have e minus ut. And then what's going to happen is we're going to have this minus t come out in the denominator. So we're going to have minus t here. We just need to evaluate this from s to infinity. But now evaluating u at infinity, that's going to be going to 0 just as long as t is positive. But t is going to be positive as we've got our bounds that way. So this first piece here is going to just give us a 0. The second part, what's going to happen, we're just going to plug in the s here. This is going to become e minus st over t. Actually, don't forget that minus sign right there, but the minus here is going to cancel with this minus sign right here. But now let's just clean this up to see what we have. So just reordering everything here, having the e minus st in front, grouping the t with the f of t, what we have right here, this thing is actually the same thing as the Laplace transform of f of t over t. And so this thing here, this was the goal in the beginning. Working backwards, all this stuff is equal. And so for our formula for the Laplace transform of f of t over t, we just have the integral evaluated from s to infinity of big F of u du. And just keep in mind this big F of u function, that's just going to be the Laplace transform of this part. So in order to set this up, hopefully this is an integral we can do. So the intermediate value we would need in order to calculate this would just be the Laplace transform of the numerator, the Laplace transform of f of t. Normally we would say this is big F of s, but in order to set this up for this integral, we'll call it big F of u, but then we're going to get our s back when we integrate this way. Okay, so there you have it, Laplace transform of f of t over t. In the next video, what we'll do is we'll just do an example using this formula here. Thanks everyone for watching. Have a good day.